Hey guys, sorry I can't be with you today. I am at a big fancy meeting over at the district office. So instead we're going to do some video notes here. Please feel free to press pause at any time. There will be a few places where I indicate that you press pause. If somebody has a question about how something happened, you have a few different options. Option number 1 would be to ask for a pause. You can discuss it as a class. My guess would be that somebody knows. If not, you can write a question mark somewhere in your notes and we can discuss it the next time I see you. So lesson 8.8 is all about the distance formula. If you haven't already had a chance to take out your notebook to get started, please do that now. We are going to begin with a homework review of a few problems from lesson 8.6, so you'll also want to take that out now. Please press pause, make sure everyone's got that handled, and then press play. Our learning targets are today, we're going to actually use a distance formula to find the distances between 2 points on a coordinate graph. There is another way to do it that you may have learned about last year. We will discuss that way briefly, but I will expect that you are using the distance formula specifically. So let's go ahead and get started. Again, we're going to start out with the 8.6 part from your homework. So this was from day 5 of your homework, I believe. Day 5, maybe even day 4 with that whole snow break thing happening in there. In lesson 8.6, you are assigned to do question number 12. Some people asked about it, not too many people, so just want to make sure that everyone is clear. Here we are looking at a right triangle with one unknown side. In order to find the unknown side, we would actually use the Pythagorean theorem. So, do you remember what it is? If you do, go ahead and jot it down now. You should have something that looks like this. A squared plus b squared equals c squared. Where a, b, and c are the three sides of the right triangle, c has to be the hypotenuse. So this time when we substitute a, b, and c, a and b are interchangeable as the legs of the right triangle, the right angle sides, but c does have to be the hypotenuse. Simplify anything that we can. Of course, we can calculate out those exponents. We should all have 81 plus 121 equals y squared on our paper. Again, continuing, simplifying what we can. We, of course, know that 81 plus 121 is 202. So we now see that 202 equals y squared. At this point, and a lot of people remember that the square root is involved at some point in the Pythagorean theorem. As a matter of fact, actually, a student asked me the other day why we don't have the square root as part of the theorem. The square root is actually what we have to do to find out what y is equal to, because we learned actually in this chapter that if we take the square root of a squared value, for example, the square root of y squared, we would end up with just a y. So in this case, we're going to use a decimal approximation again, because 202 is not perfectly square rootable, and it doesn't have any perfectly square rootable factors. So we will be left with y is about equal to 14.21, 14 and 21 hundredths. Similarly, I believe then on day 6 of your homework, you were asked to find the missing value in this right triangle. Again, using the Pythagorean theorem, we'd substitute in the values that we know, a, b, and c. Again, the only one that really matters that much is you have to get c in the right place, and in this case, c is 25. So simplifying what we can calculate those two exponents. 16 plus y squared equals 625. In this case, simplifying what we can, what we'd really like to have happen in order to solve for y is we'd like for the 16 to be gone. So we get rid of that extra addition term by adding the opposite of both sides. And if we add negative 16 to both sides, we'll find out that y squared equals 609. At this point, since we know what y squared is equal to, we would want to do the square root on both sides so that we know just y, because the square root, again, of y squared is just a y. And since 609 is not square rootable, nor does it have any square rootable factors, we would give the decimal approximation of 24 and 68 hundredths. So again, that was just a review of the Pythagorean theorem a little bit here, seeing some more square roots. Couple of homework questions that a few people had not asked about that might show up on the test or the quizzes that we do have coming up. And it also will definitely help us with what we're doing today when we start talking about the distance formula and even just distancers on the graph in general. Taking a look here, we are going to be finding some distances on the coordinate graph. We can find distances by graphing. just straight up by graphing. So here we're looking at the distance between A and B. I often think about the coordinate graph kind of like a map of the city where the lines that we can see are roads. For example, if I needed to drive to A from B, I could follow this road here. However, if B were down here, I couldn't just cut across all the blocks and run over houses and yards and everything else. So most of the time on the coordinate graph, we want to think about driving distances. So following the roads here. If we want to find the distance from A to B, we just drive right along this road that was already formed, and we can count it out. The distance from A to B is 15. If we want to look at the distance between D and E, here we've got D graphed at 2, 7 and E graphed at 2, -7. Again, we've got a road that we can follow. We just count it out. We're right here. It actually is 14. So as we take a look, vertical and horizontal distances can be counted along the roads. Things do get a little bit trickier if we have points that do not have a nice road distance that we can count out. The diagonal distance, or an oblique distance, isn't quite as easily counted, but it can be found using the Pythagorean theorem. The Pythagorean theorem, of course, we would want to have some right angle sides here. So A and B would be following along roads, so to speak. So if we wanted to know the distance from Q to P, or P to Q, we could follow along the roads here. This road would be 8, and this road would be 9. We could go ahead and follow through with the Pythagorean theorem that we just saw in the 2 homework questions. And this is one option that we have. This would be considered kind of the backup option. If I'm absolutely stuck, I can't remember the formula, worst case scenario is that we can graph it, we can build the roads, we can build the right triangle and use the Pythagorean theorem. Today our goal is more based around using the distance formula. So we actually have something called the distance formula that we're going to go ahead and take a look at here in just a second. So when we talk about finding distances using the distance formula, again, we can always build our right triangle and use the Pythagorean theorem. It's a lot more work, it's a lot more involved. You have to remember how to graph, you have to remember the Pythagorean theorem. We have a shortcut way of doing it where we don't have to build the right triangle and use the Pythagorean theorem. There is a formula that can be used, and that's really kind of our concentration today, is making sure that we know how to use this formula. So the distance formula says the distance between any 2 points, x1, y1, and x2, y2, can be found using the formula. Earlier today someone had asked, is this just like slope? And no, it's actually not just like slope. It will look familiar to slope just because of the labeling. We have to come up with some generic points rather than putting numbers in. So we have a first point with an x coordinate and a y coordinate, and a second point with an x coordinate and a y coordinate. Our formula looks like this. It is the square root, a nice long square root because there's a bunch of stuff going on underneath, of x1 minus x2 squared. Yes, the parentheses are necessary, plus y1 minus y2 in parentheses squared. So right now we're going to take a look at an example of how this works. I could ask you to find the distance A to D if A equals 6, -5, and D equals -4, 9. Again, we could always fall back to throwing it on a graph using the Pythagorean theorem. That's not our goal today. Our goal today is to be able to use this distance formula. So you may have to press pause at a few different times to make sure that we all get this written down. If you have a question, feel free to ask it. There's a good chance that somebody in class might be able to answer that question for you. Or if you're not sure why a step happened and you want to ask me yourself, I'll just put a question mark next to it and remind yourself I'll ask for questions next time I see you as well. So let's take a look. The first thing that we would want to do is make sure that we know the distance formula. The distance formula, again, is the square root of x1 minus x2 squared plus y1 minus y2 squared. So entering our values here, and I'm just going to assume that the first point A is 0.1 and the second point D is 0.2. Well, we need to substitute our known coordinates. So we see 6 minus -4 and -5 minus 9. So again, I just went with the first coordinate that I saw as being x1, y1, and the second ordered pair that I saw as being y1, y2. So right now, let's push pause, make sure everyone understands why each number went where it did. Help each other out. All right, we know why everything went where it went. Let's go ahead and calculate. Start in parentheses, of course. 6 minus negative 4 is 10. Negative 5 minus 9 gives us a negative 14. If you're not sure why that happened, go ahead, press pause, ask a neighbor, or write a question mark to talk about next class. Calculate our exponents next. 10 squared is, of course, 100, and negative 14 squared is, of course, 196. You'll notice we're not taking any shortcuts. We're not dropping the exponents, all because that addition is stuck in there. So we do have to go ahead and follow through on the addition. This is the square root of 296. Now, square root of 296 is not a perfect square, so it is not square rootable. But it does have a perfect square factor. Since 296 is the product 4 times 74, and we've chosen the 4 and the 74 because we know the square root of 4. 74 is not a perfect square, nor does it have any perfect square factors. So when we simplify this out, the square root of 4 would give us a 2 outside of the square root, and we'd be left with the 2 times the square root of 74. These are your notes for today. Your job will be to work on your day 7 homework. You can see that on the board, 8.7, 8.8, and the self-test. You can omit number 18. You are working on the self-test over or before next class, because next class is your in-class study day, preparing for the Chapter 8 test, which is happening, of course, next week on Tuesday, the 13th. We'll also be taking another quiz next class, as well as wrapping up any quiz corrections from the chapter, just to make sure that everything is all settled and ready before you start the test. Go ahead and get started on your homework. There is an answer key floating around somewhere, as well as your self-test answer key, which is, of course, in the back of the book. Have a great day. We'll see you on Thursday.